Hello everyone, welcome to my session. My name is Herman. I currently work at Lottie, a company specializing in motion graphics design and solution, and I'm the creator of a ThorVG graphics open source project, which is about the vector graphics development project. In today's talk, I would like to give you an overview of motion graphics with a trending Lottie animation and ThorVG graphics project, exploring what they are and how we can incorporate them into our modern application features. Since time is short, let's jump right in and explore them together. First of all, what is motion graphics? Simply put, you can think of it just like moving visual content, much like animation. And these days, the motion graphics is very common. It's widely used in industries, especially in design. It actually helps to deliver content more clearly and make it easier for users to understand the content. And engineering perspective, vector graphics is the foundation of modern motion graphics today. And for those you who are less familiar with vector graphics, please let me walk you through it briefly. As you might know, bitmap images like a JPEG PNG, actually they store fully rendered image pixel by pixel. In contrast, the vector graphics stores only the mathematical information for geometric shapes and rendering images at runtime by interpreting those formulas. And this fundamental difference makes vector graphics ideal for a wide range of applications today. One of the greatest advantages of vector graphics is that it's a resolution-free, scalability. It can be displayed on any size of display and any resolutions without losing quality, while making data sizes quite compact and small. Another key advantage is that it's a flexibility. Since the shapes are defined by mathematical formulas, developers actually they can easily adjust the parameter values to modify features in real time, making vector graphics more powerful for moving content. And historically, SVG was the most widely used format for those vector graphic asset in the industries. However, in the past few years, Lottie has emerged as the go-to solution for animated vector content. And since the motion graphics have become trendy, now Lottie is really popular and used everywhere. There are several well-known vector graphic engines you can consider when you're building a custom graphic solution for your project. And one of the most popular one is the Skiar. Skiar is from Google. Skiar actually has the extensive rendering features as well as its rendering performance is well optimized with the hardware accelerations. However, today those decent vector graphics is quite complicated, and those complexity could be problematic when it works on some resource constrained devices. And that is one of the reasons why we started a ThorVG project, aiming to strike the balance among the portability, feasibility, performance with modern style interfaces. So we'll take a look at ThorVG project in the next page. Before that, let's move on to Lottie. Lottie is the open standard. It's quite efficient, scalable, cross-platform vector graphic format. Originally, it was designed by a developer. The name is Hernan Torres. After that, Lottie has been further developed by Lottie animation community, which is working group. Today, actually, they continue to refine and develop Lottie animation specification. So now we can actually say the Lottie is an industry standard because it's so widely used. Even Lottie Linux Foundation officially supported that project. And personally, I also prefer to use the Lottie rather than SVG because even though Lottie was designed for animation live from the get-go, often it results in smaller size compared to SVG while making efficient and compact runtime performance. But the most of all, designers they really love to use the Lottie because it's just so easy to use and functional and works well across different platforms, giving designers more freedom for expressing their motion design creativity. Then you might wonder how we can design Lottie and how we can apply it into our product, right? There are some couple of a couple of well-known design editors tools. I mean, for Lottie, one of them is the Adobe After Effects and the Lottie Creator from Lottie Files. Lottie Creator is the born to Lottie, which means that it actually have been designed only for the Lottie animation. So it's well aligned with the Lottie features and its specifications. Even it's a really compact and web-based application editor and free for everyone. So you can consider if you are looking for some certain Lottie animation design editor when you start the Lottie design. So yeah, it's good. And ThorVG graphics is the key vector graphics engine that supports the Lottie animation. And I would like to introduce one more project, DotLottie. DotLottie is kind of like an advanced version of Lottie format. So we'll also take a look at this project in the next soon. ThorVG graphics is a fully open source project being developed by more than 7 active contributors today. And the project was actually started in 2020. It's almost 5 years old, and on track to release the official 1.0 soon this year. Most of our ThorVG is a graphics engine, but it differs from traditional vector graphics libraries such as Sketch. While ThorVG supports essential drawing primitives like drawing line, drawing circles, drawing fill color, something like that, but it also provides a retained-based rendering mode with the manageable drawing object and scene graph. This means that ThorVG actually handles much of a complex drawing process behind the applications, and I only need to manage a drawing object and update their properties as needed. Then ThorVG automatically execute the appropriate rendering sequence. Another major advantage is that ThorVG supports both SVG and Lottie out of the box, which are industry standard vector graphic format most today. So you don't need extra libraries or plugins for those format support. ThorVG instead implemented those features efficiently, making both powerful and easy to use. Another big advantage is portability. ThorVG can run on any platform or system without external dependencies. Even each binary size is super small. For example, if you build a ThorVG only with the basic drawing primitives with the software rendering engine, it only takes about 150 kilobyte, making ThorVG ideal for small IoT devices. Even with the Lottie support enabled, the build stays around less than 400 kilobyte, which is still extremely compact. Based on this characteristic, ThorVG is also web-friendly through the WebAssembly mechanism. So if you are a front-end developer and if you are looking for some custom graphic engine for your web application, probably ThorVG is one of the options you can consider, even though it's not some common case. Anyway. Until now, ThorVG actually supports only the Lottie animation features on the web, but we are actually working to bring the ThorVG full features as the canvas kit to browser-based environment, targeting by this year. About performance, ThorVG software rendering is both lightweight and very efficient. Besides, ThorVG also supports hardware acceleration such as OpenGL, WebGL, and WebGPU. And to the best of my knowledge, very few vector graphics engines currently support WebGPU. ThorVG is one of the ahead of curve, particularly in the web ecosystem. Lastly, ThorVG has been designed with the modular architecture that makes integration flexible. Officially, it relies on a measure build system, which lets you easily toggle ThorVG features through the build options. And this means that you can enable only the features your application need, which helps keep the binary size small and reduce both the integration complexity and the maintenance overhead. So until now, ThorVG has integrated with several open source projects. For example, Tizen Platform, Gata Game Engine, and LVGL GUI frameworks. Also, it has been integrated with some certain products such as the graphic editor tool, some indie games, some special visual effect for audio application, and the design editor like a Canva, something like that. Also, ThorVG has implemented WebGPU as it's one of the random backend engines. WebGPU provides a next generation API similar to Vulkan that leverages the computer shader and offers low overhead, modern GPU access for more aggressive optimization strategy and broader applications. And furthermore, unlike WebGL, it has no instance limitations, enabling multiple ThorVG engines to run simultaneously. This means that we can actually launch ThorVG engines as the Lottie animation player more than 50, more than 100 at the same time on the same screen. In case of WebGL, it actually has the 16 number of instances limitation in general, I think. So it's not quite compatible with ThorVG engine or something like graphics engine. Practically, actually, some project might have some these instance limitation issues. For example, Scotty. Scotty is a scale-based Lottie animation player. It actually has the same problem, so you cannot launch more than 60 animations at the same time. Additionally, WebGPU helps to enhance the portability by abstracting the underlying system graphics layer. As you might know, there are some certain hardware accelerations like Metal, DirectX, and Vulkan. ThorVG doesn't really depend on those hardware accelerations directly. Instead, it just look up the WebGPU layer, and WebGPU instead redirect the hardware accelerations which is available on a current system. It means that ThorVG can be adapted on any platform regardless of the installed graphics hardware accelerations. So it can run on WebGPU or WebGL or OpenGL or software rendering engine. So users can pick up the right rendering backend engine based on their runtime environment and the device GPU capacities. And lastly, ThorVG supports most of the vector rendering features within each spec on top of WebGPU. But WebGPU project itself is also under development, so we actually continue to refine it for better product level quality as WebGPU update progress further down the line. Another special feature is that ThorVG is built-in multi-threading and task scheduler, which enables the fine-grained parallel processing to boost the sim building and rendering performance. For example, when you enable this feature with the number of 4 threads, you might be able to gain twice faster. However, this actually requires a system that supports the threading, and unfortunately, it's not available yet on a web environment due to web threading security constraint. We actually hope that changes soon. But anyway, you can take a full advantage of this feature, task schedule feature, on native or embedded system where the threads are available. And if you are working on the front end, you might want to explore the web workers to parallelize the certain runtime engines like a ThorVG graphic engine. And actually, DotLottie player in the next will check actually handle over this web worker optimization with the ThorVG instead. So if we are looking for if you are just considering the Lottie animation support from your web application, then DotLottie player might be a better choice rather than direct ThorVG integration. Today, ThorVG offers one of the most comprehensive and compatible Lottie animation runtimes available today. According to our metrics, ThorVG supports nearly 100% of the current official Lottie spec 1.0 is quite qualified as the Lottie animation engine. And thanks to this strong compatibility, ThorVG guarantees the consistent behavior and performance across all platforms. One of the most common issues with the Lottie is that often its rendering results are different across platforms due to variations in feature support among different Lottie libraries. For example, there are Lottie Web, Lottie Android, Lottie iOS. There are several Lottie animation libraries existed, and they actually have been designed and developed for specific targets. The different targets. So their implementation method and the feature coverage could vary, that leading to differences in Lottie rendering result. And this inconsistency Inconsistency can be problematic for applications because we actually expect the identical animation result across all supported platforms. However, ThorVG naturally can resolve these problems by providing uniform playback experience. Since its portability is great, you can just integrate the same ThorVG engine across different versions of your application packages for each target, so you can just ensure the consistent result. Also, beyond the default plain loading animation, ThorVG supports advanced loading features such as the slam marker and expressions, which allows the dynamic property change and state-based animation and high-level controls for user interactive animations. Basically, ThorVG utilizes the Lottie's named segment features, also known as markers, to support state-based animation. Also, as shown in the figure on the right, there's one single animation can have a multiple segment, in this case three rectangle circle star. This means that this animation has the three named segment as a state. And here is the point that makes the ThorVG special is that it actually has the ability to smoothly transition at any point between two animation states. Actually ThorVG provide a function that interpolating arbitrarily different frames of the two state scene information, even if they are non-consecutive segment. For example, you can see in the demo on the right, state tuning, you can see a character slowly learning and then suddenly speeding up. So it actually has the two animations. One is the slow loading and the other one is the fast running. Even if the transition happens at any certain frame number accidentally, ThorVG ensures the smooth transition by interpolating between two non-consecutive scene information. So eventually, it helps the application supporting more natural and seamless state-based animation playback. Another notable feature support is that user interaction. ThorVG provides an engine-level hit detection support, enabling applications can figure out which element in a loading scene have been selected. With this logic, developers can create responsive animations based on user interactions. As you can see a demo at the bottom, lock animation. Actually, the title is the hit detection. You can see there's one single loading animation, but applications can figure out which button in a loading scene have been selected or not, so they can bring some more responsive animations based on user's input. And lastly, ThorVG supports the loading expressions. Expression is a lightweight and JavaScript-like a scripting method originally used in Adobe After Effects. It allows to add small-scale logic to specific part of animation. For example, you can see a code snip at the bottom. You can see that something like we can actually address some kind of a small logic like JavaScript. In this case, actually the logic is about the bouncing effect of a windmill. And we can actually attach that logic to some specific part of the loading animations so that we can bring some animation variations at runtime. One more example is that spinboard animation demo, which you can actually find at the bottom in the middle of the right side. This animation is actually also a single loading animation, but actually that contains both the finger and the spinboard. And as you can see, we can change the finger position as well as the spinboard rotation values through the expression variable values in real time. So I think actually this demonstrates how applications can make a loading animation more flexible and interactive. Again, with the expressions, designers or programmers can add a simple logic to animations at the design level while also giving applications opportunity to change their loading element parameter values within ThorVG, making them more dynamic and responsive to user input. One more thing, expression can also be applied with the two impulse constraint, ensuring that certain animation properties stay within a specific range and preventing unintended design deviations. As shown in the balloon animation in the lightmost, User drags the moving balloon and changes their position, but they never go outside a certain area. This kind of a constraint enforcement can be achieved using the expressions by addressing range conditions and exception handling to ensure the balloon position always remains within the designated area. So all in all, ThorVG is the only library that supports state twinning and expressions. Most other Lottie engines do not offer those features today. Lastly, let me introduce the DotLottie project. DotLottie is an extended version of the original Lottie format designed to enhance the Lottie's capabilities by providing advanced feature set. One of the benefits of DotLottie is the multiple animation support. Within a single DotLottie file, DotLottie can add multiple Lottie animation data, also bundles additional assets such as image, sound, and theme to share them among multiple animations. But it's not just a collection of Lottie animations and their assets. Rather, it's more like a compressed data structure containing all the data zipped together. Basically, the Lottie data size can be reduced through the zip compression mechanism, so that improving the data transfer speed over the network, or reducing the application package size, or maybe it helps to improve the application loading performance by reducing the memory bandwidth overhead. Even for a single animation, the size can be significantly reduced. For example, as you can see in the flying animation demo at the bottom, the file size was actually reduced by up to 70%, so it's really worth to try DotLottie instead of the original JSON Lottie file. Additionally, DotLottie supports advanced features such as state machine, theming, and interactivity on top of a ThorVG engine. We actually explored those features in the previous pages, so let's skip the details. The point here is, with the DotLottie format, we can actually achieve these kind of advanced features in a more structured and efficient way compared to implementing those features directly with the ThorVG and original Lottie asset. Actually, DotLottie support a library, DotLottie player library, with the more convenient interfaces, and it actually handles some complicated stuff under the hood. So to use the DotLottie format in our application, we can actually leverage the DotLottie player library, and this library is actually built on ThorVG and provide a high-level user interfaces, while supporting various platform integration through the dedicated packages such as DotLottie Web, DotLottie Android, DotLottie iOS. Also, since it's built on ThorVG, DotLottie ensures the consistent rendering quality across platforms. Also, it directly integrates animation loop and event system over a target platform instead of applications. So apps just easily use the DotLottie player just like a simple UI controller. And lastly, DotLottie player is open source and actively evolving. You can also use the editor like a Lottie creator to design and implement the DotLottie's unique advanced features for your advanced UX application UX. So if you are interested in enhancing application UX with a micro interaction style, DotLottie might be an interesting project for you. So please check out the DotLottie site for further details. Thank you.